Permutations. For permutations, another way you can think about them is arrangements. Permutations are arrangements where order is important. So an internet site access code consists of 3 digits. Knowing the 3 digits is not enough to access the site. The digits have to be entered in the correct order. The order of the arrangement of the digits is important. John cannot remember the access code except that it contains the digits 3, 5, and 7. So let's list the arrangements. So 3, 5, 7 is possible. 3, 7, 5. 5, 3, 7. 5, 7, 3. Or 7, 3, 5. 7, 5, 3. So basically there's 6 options. And if we used fundamental counting principle, it would be like this. There's 3 choices for the first digit times 2 choices for the second times 1 choice for the third, which equals 6 options. So when we think of permutation, we think about order, we think about position. Position is important. Okay, permutations of n elements taken n at a time. So list all the arrangements of the word cat. So we have C-A-T, or we have C-T-A. We have A-C-T, or A-T-C. We have TAC, or we have TCA. Write the number of permutations in factorial notation. So 3 times 2 times 1 is 3 factorial. 3 times 2 times 1 is 3 factorial, which equals 6. Now, this is an example of the following general rule. So the number of permutations n of n different elements taken all at a time is n factorial. So the way we write this as a permutation is we have P for permutation or for pick. So we have 3 elements and we're going to pick them 3 at a time. And that is going to equal 6. Now, I'm going to show you some examples here below. So the number of elements is the number in front. How many you're taking each time is the second number. So determine the number of permutations of the letters of each word. So we have the word Regina. So Regina has 1, 2, 3, 4, 5, 6 letters. So as factorial would be 6 times 5 times 4 times 3 times 2 times 1. Because there would be 6 choices for the first letter, and then once you've decided on that, like if you decided on the G, then there's 5 choices for the next letter, and so on. So that is 6 factorial, which comes to 720. Now, let me show you how this would look as a permutation. So we have 6 letters, and we're picking them 6 at a time. I'll show you how to do this on the calculator now. So first you put in the 6, the number that's in front of the P. Then you go to math and go over to PRB, probability. This time you go down to number 2, NPR. Press enter. And then you have 6, pick, permutation, and then put your other 6. And then press enter, and you get 720. So let's try for Kelowna. I can go. I have 1, 2, 3, 4, 5, 6, 7. I have 7 letters. And I want a permutation of those letters. And I'm taking them 7 at a time. Let's put that into the calculator. Seven, math, over to PRB, down to permutations, enter, and put the other 7. That's 5,040. Now, going on, if we have a word like graphite, and graphite has 8 letters, but let's say we just want to have 3-letter arrangements of the word. So I only want to choose 1, 2, 3 of the letters each time. So for example, I might want to pick just like a G, an H, and an E as one of my choices. So how many different choices, 3-letter arrangements, are there? So with the fundamental counting principle, I say, well, there's 8 choices for the first letter. If I use the G, then I have 7 choices for the next letter. So let's say I use the H, and then I have 6 choices for the third letter. So that comes to 336. Now, in the example above, we have found that the number of permutations of n elements taken 3 at a time is denoted by 8p3. So you can do a permutation question as a fundamental counting principle question. Here is the next is showing how you could show with factorials. And then the last one is hinting towards this formula that's on your formula sheet. So this would simplify to 8 factorial over 5 factorial. And the answer for any of these is 336. Let's go on to the top of the next page. And the thing we have to note about defining 0 factorial is that it has the value of 1. The key thing to remember, just in review, is 2 factorial equals 2 times 1. 1 factorial is just 1. And 0 factorial also is 1.